So I'm doing this with my DSH hat on. I have many hats. DSH is a workshop, cooperative, consists of Fabiola. She's pretty much got everything certified. And LabVIEW champion, we're all LabVIEW champions. Jörg is owner of Hamsoft, which is the first NICE Center of Excellence for Germany. He's also certified everything. They're both CPIs, as is Brian. Brian is our latest member. So there's 4 of us. So you got me as well. I've also written a book, blog. I'm certified LabVIEW architect and LabVIEW champion, and also my company is a Centre of Excellence, which is why, as a scruffy, you might want to listen to what I say about process. In case you were sat here wondering why should I listen to this scruffy process. So yeah, we do workshops all around the world, trainings. Type training. The other 3 are CPIs. I don't really like training. I do. I'm not a CPI. Oh, get one, sure. Do that, don't that. Work out how to do that. But I do one. Use that one, use that, previous slide. So I'm going to talk about sort of brain dump. So we all have 4 quite different companies, but we all are very into sort of similar things. And it's kind of interesting how we tackle things differently, which is actually the main point of this, is that everyone here, you can tackle things differently, but there are similar problems that we're trying to solve. So problem number 1 is what stops us from completing projects. Now, if you paid me some money, we could sit here and talk about that. You get the free version, which there's many reasons. My bag is that delivery is all. As a software engineer, freedom. See, I'm free to look like I've been dragged in off the street by a dog, because I deliver code when I say I'm going to. So if I say I'm going to deliver a system, I tell you a price, I'll tell you a time, and generally we try to get to that. We don't never change the price. That's a flexible thing. So I'm really big on that. So the whole thing in my whole career really has been, give me a project, I want to do the project, I want to go to my next project, I want to go to the next project, I want to churn out. And my company in the last 20 odd years has churned out 100 projects, big and small. You know, we do a lot of work. So how do we do all of that? I'll just press the space bar. So there's a big thing about Agile going around, and everyone says they're Agile and they do all this kind of stuff. Trouble with software engineers is a lot of what they mean by Agile is not what managers mean by Agile. It's certainly not what QA people mean by Agile. So for a lot of software engineers, Agile means I don't have to give an estimate, I'm just going to mold something. You know, and eventually you'll get something that looks like code. Managers don't tend to think that's what Agile means. They want a price and the time. So there is actually at the heart of Agile a lot of good. So Agile was ruined by process project managers, generally. Have I got my Agile slide? I think I may have deleted it. Discuss. what I like a lot about Agile that's where it's all going wrong. So this is, so you've got a way of writing software, and there are things you need to take into account. This is some person put that up as this is the Agile landscape. So yeah, self-delete. Too many computers, too many keyboards. Bye-bye. So the first thing you've got to do, if you're thinking of getting ISO 9000, for example, or you're thinking of CI or CD, something automating your process, the first thing you've got to do is have a process that you can automate. And a process isn't the person who's doing the automation process. It's not the guy who's trying to get ISO 9000. So the common mistake a lot of companies make is they say, QA manager, go and get us ISO 9000. He goes and then writes shitloads of manuals, and he imposes all of these things on his team that he has to do, and he then spends his next, until he leaves the company, in frustration beating people, trying to make them run this process, which isn't very good. You know, what you've got to have, I like the term, and Jürgen and me love this term, is to have a way of working. Just have a way of working, get that down first. Your group, speak together, talk about how you like to work, what things fit, and then just write that down. You know, just write that down. This is the way we like to work. And there are essentials in the whole software process, but start with a piece of paper. Start thinking about having a way of working for you and your team, and you get the team involved. And also know who your stakeholders are. So by stakeholders, I mean managers, I mean users of the software. It could be, you know, if you're owned by a company and the company manager is paying you money, it might be his boss's 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 boss. And a lot of the software process is a human thing. You know, you're taking fear away from worried people as an engineer. That's a big part of a good engineer's task, is that you try to make your manager less worried. So just make your life easy. And this is a term I use a lot. So I do quite a lot of large jobs that are very risky. I'll give you an example. There was a big meeting with me as the programmer and 10 project managers, all above me, all being paid much more than me, all looking down upon me. I'm the one doing the work. And there's a lot of disparate sort of people here. There's financial people. This is a big money job. And that question sort of unties a lot of nonsense. So you'll get a long list of sort of, you know, they'll come up with a Gantt charts. These are this, yeah, you've got to finish this by this, by this, by that. And the question is, what does success look like? What to you? And who, everyone in the team, get them to say, this project, what does, because it can be a lot of different things. Sometimes it can be, I just need a design review in a year's time, and I need to then push that up into the management to show something done. Whereas your requirement is to get everything done in a year's time. It's useful information. That is a true story. So, start our plan. So, what we do with this is an SSDC thing, but the way we keep our process agile, but also keep it under control from a QA perspective, is that all of our projects have a project plan, and that project plan is just a big template that you cross out all the bits, and you just essentially is what you would tell your stakeholders how you're going to run the project. One of the most important things in the project plan is is the customer signature. Who's going to sign off this project? I mean, for us, that's the person who's going to tell us that we're not getting paid. Okay, feel pretty positive, non-British about it. But it goes through all of the important aspects of a project, and we do this for every project. And it doesn't mean you have to rigidly follow a particular methodology. It's just that you say what you're going to do, and it also it's active. That's an active document, so you can change it. You know, there's no reason you can't change a document. It's only because people are scared of management. I know I've worked in aerospace, I know why it is. It's because they're scared of any changes in the documents. But in software, you don't have to be worried about things like this. So this, and I found this is great. If you get audited, you just hand over. You say this is a project, this is and that's just cross-reference of everything. That works really well. So what is a good software process? Now, we did years and years and years ago, we did a brain dump of all things that go into a project, all the different processes we have, even down to sort of personal attributes. You know, I've worked with people who shouldn't be allowed near other people, and they drag a project down. And you know, I don't buy into that. Oh, I'll change him. I'll make him better. I don't buy into that. Sometimes people need to be ejected. With violence, sometimes, I think. But so yeah, this is actually. I mean, it's probably too small to see, but it's just a brain dump. We'll go through everything else, but generally it goes through a project from start to end. It also has a lot of support processes thrown in. But if you do a version of pretty much everything there, you'll have a project that is in control. But you don't have to do all of it. You just do the bits that are important to you, because everyone's company and stakeholders are different. They want different things. So this is a big list. So support processes, important ones, which I think everyone should do. This is, we agree to between us, is version control. I'm going to talk about that. I think everyone should do issue tracking of some sort. Source code control goes without saying. There's important aspects to deployment, which probably everyone ought to think about at the start of a project, which they often don't. Bung all that together and say how you do it. I don't care particularly, but if you do some of those things, you'll make your life easier. Go through very quickly. I'm not going to talk. Everyone uses source code control. I don't want to know if you don't. just you should use it, even if you zip it up and with a version number. I don't care, but don't. It'll help you. This is a helpful thing, and it's free. It goes beyond just how do you manage software updates from multiple developers, which is what I've tried to do is, or we've tried to do, is put a sentence that describes that. I liken it to you've only got one version of the code on your computer, not 100 different ones. So cross-linking is not such an issue, but just generally management is not an issue. You know, it's nice to say, this is my project folder, this is the project I'm working on, and it's only the code that's there is the code that I'm working on, not spread all over everywhere. That's close to me at the moment because I've just picked up a project to repair. This is the antithesis of that. Even got VIs, the version number in the VI. So what you could do with version control, this is different than source code control. This is how you make your source code traceable. So if you're looking at an executable, a DLL, an FPGA, we call it bitmap, anything that you build, a result of building source code, you should know what source code you've used to build that thing. The way, and do it with their application builder is not that helpful. So we always make a central part of our first sort of deliverable is how do I find out what the source code is with version, so I can go back into my source code control and rebuild it exactly the same. I'll give you a load of examples. But you use it for two reasons, really. You use it so the end user can go, I've got version 4 and I wanted all these changes and you haven't done them yet. And you can say, well, that's because I haven't released version 5 yet. It's not. So it's a way of communicating between developer and end user. But really the most important is that you need to be able to traceably build something. You need to be able to, when they say I use version 4 and it's got this bug, you need to be able to rebuild it and it is actually version 4. I can give you some horror stories if I had time, but I don't have time for that. Nice without it. So all we do at SSDC, I think others in DSH do, is I just have a little version of VI constant VI. We quite like constant VIs because you can make them automatic, so you can update them using scripting, things like that. Link it. I mean, I've linked it to Subversion sort of commits and things like that. Do all that kind of stuff. That's cool. Come out of the front panel, and you can also use it as a startup, as a splash. Just use the same VI. But front panel was the important bit, and just hand wire it. Doesn't matter. You know, it doesn't have to be part of the name or anything like that. It's a central and important piece of your user interface. It's also a central and important piece of when you connect to something like in RT. So when you connect to it, if you're using UDP, make part of the packet that you transfer to each other, it's the version number. So you always know what software is running RT or on the FPGA. So RT is pretty much the same as in normal LabVIEW. FPGA, our way of doing it is really dumb. You just bung that on the front panel, and then you can just query it. You update it, you just update it. Means you have to update it manually. Okay, but I think sometimes LabVIEW programs could just slow down a little bit. Just do a little bit this way, make the life a little bit easier. Semantic versioning, I won't bore you with that, you can look it up on Wikipedia. That's what I've done with that slide. Issue and task tracking. So, straight in. If you use Jira, you're probably ahead of me. All I've done for my company is I've taken the Bugzilla database and put it up on a cloud Unix server and write a load of LabVIEW to link to that. That's fine. But it is whatever you should do. If somebody says anything to you, if they say, I'd like the screen green rather than blue, they're wrong, but you should just know that. Because and so we run I prefer issue to bug, because often issues are not bugs. But it's really a communication from your user that they'd like something changed. And you can say, I've given you enough on it. This process should be under control. I've been caught out when the process was not under control and I was being a good supplier and making loads of changes based on what the user was saying. It transpires the management didn't want to make those changes. So actually having a coherent, again, way of working where you have a process that says you want me to make a change. Okay, here's a piece of paper that says, can I have this change? I'll give you a number. I'll tell you what the risks are. I'll tell you what tests I need to validate it. Oh, look, and here's a little signatory here for your boss. You can sign it if you wish, because then you've taken it on the chip. But somebody has to take responsibility for this change. It's just standard sort of engineering change control. It's not magical because it's software.
So Steve, if you're in your design phase and managing tasks, what sort of granularity do you tend to go down to when you're documenting it in your system?
In design phase, it's different. You're not released we issue track early, so we usually beta release to a customer early. And we declare it. We say, here's the beta, it kind of works. Off you go and test it. I'm not a big believer in testing it. I don't think it works so well. So it doesn't. It always passes magically when I test it. It's fantastic. But at that point, when we're in beta, I'll go for it actually. But in that point, we're issue tracking properly because we want to push into that system as always, because spreadsheets and requirements tracking is boring. That's the more boring side of it. Yeah. So I prefer. One of the benefits of LabVIEW really is we do requirements tracking, but one of the benefits of LabVIEW is that you can get interactive with the people you're developing for. So you want that process to be as flexible and quick as possible, while still covering your ass for the just not getting lost. I'll talk about discovery in it wouldn't have been good. This is very early on in the process, but it's really beneficial to do this early on in the process. If you've got a machine, just do this at the start of the process and say, look, I'm going to give you something and we're going to test it's working. When you leave it to the end, there's going to be a point in time when a customer wants stuff done and wants updates quickly and wants all. You don't want to be there going, oh, now I've got to go through your IT department and get software in and all. You've got to get those hurdles out of the way. And if you can get it all done remotely at the start, it also makes a big difference to the price of the job. If I can deploy to your machine from my comfort of my office, it's significantly cheaper than me coming here, for example. So it's one of those things that you should work on right stuff. Don't have a process that's super simple. Again, this is things just worth thinking about. I'm not going to tell you now. I can tell you now. We go through the hows in the rest of it. This is a full one-day workshop. This is like the first session. This session is to try and get people's heads around all the things that they then want to think is important, and then we can concentrate on things that are important. Yeah, that's basically that would have. Ask the question again so I can do it. So even though discovery is there, that's really initial discovery, because discovery doesn't actually stop until there, until that last bit when you walk away from the job. And even then, you're in the support phase of a project. So it's not as though discovery ever ends. You're always learning more. But in common parlance, it's kind of a lot of it is at the start of the project. So the requirements, risk planning, estimating, again, there's a project plan. So essentially at initial inquiry, most of the way we work is fixed price. We would go through the requirements and the understanding would be we're going to get 50% of the requirements at that point. So we've had a job we've been asked to estimate before, and it was literally a computer on a desk with some instruments also on the desk. The same desk to make it easier. And can we have a price for this? Yeah, that wasn't 50% of the requirements, but we then have a few common ways of doing it. Certainly me and you have a common way of doing this. So talk about that, which we're for. So we would then do a requirements spreadsheet, and that's all it is, a spreadsheet. We don't do anything complex. The important thing is this risk. So every requirement, and we tend to do top level. So if you say to me, I want you to integrate an oscilloscope, that's one requirement, integrate the oscilloscope. and that's it. If there's 15 types of oscilloscopes, that's 15 requirements, but it's, you know, each dump of work is a quite a high level thing. But what you then would do is apply a risk score. One is low in our partners, high is 5. And if it's a 5 or a 4, that tells you haven't got enough information to quote. But so it could be a fixed price, or you haven't got enough information to say this is going to take a week. You know, you can't do that. So if somebody comes out with a new piece of equipment you've never seen before in your life, it's plugged in USB with its own set of .NET drivers, pretty high risk. Don't quote that one fixed price. Just don't, especially if it's from a guy in his shed in Israel. I said Israel specifically because that's one that hurt me when I did that. Lovely bit of kit, bugger to integrate. But anyway, so that risk is important because what it does is it allows you to say, well, these are 5s. How do I mitigate that risk? You've got a piece of paper and we evaluate that risk. You can give that to your customer. Say that, you're a customer. I want to quote this fixed price, can't, because this equipment is, I've never seen it before. How do we mitigate that? You can say, why don't you lend me that bit of equipment? I'll do 4 hours, have a mess around, see if it's any good. Then that score may reduce to a point where I can give you a quote. You know, there's various mitigations. The ultimate mitigation is that the customer takes all the risk, and you say, you have to pay me by the hour. You know, and we've had it, if you work for a university, for example, and they say, one of our students has made this piece of kit, which is just awful sinking feeling you would get when that happens. And you just sort of say, well, I'll just work by the hour on that one. Just give yourself a penny. That's wet. But you've got a document there and you've thought about it. That got added as part of our entire process because we got undone with a couple of requirements we just looked at and talk about that feedback into the process. Estimating. This graph is from a book called Waltzing with Bears by Tom DeMarco. If you can call yourself whatever you like. If you're writing software for a reasonable percentage of your day, and that's what you're being judged by your management, you're a software engineer. So read software engineering books, and some writers are better than others. So don't read Bob Martin, read Tom DeMarco. Mainly don't read Bob Martin as he's hard. But and Tom DeMarco is really good. So, but this is a interesting graph. So manager says, when's the earliest you can deliver this? Well, the earliest is there, and that's called the nano point, I think, because you've got like 1 in a billion chance of achieving that delivery. We as software engineers, we as engineers work to that nano point more than we should, because that's the earliest. If everything goes well, that's the earliest. The next big mistake you do is what is the most likely? Well, again, there's a lot more after this graph than there is in front of it. So we think that that point there is the most likely. Well, it's not actually. That's your 50-50. We're going to make this 50-50. You know, half the time it's going to work, half the time it's not. So it's a very useful graph to keep in mind when estimating, because project managers like to know the earliest. And 1 in a billion times you'll get that. Awful lot of pressure. We also tend to think in the positive. We never think about things that don't work. How many times have you estimated, included in your estimation, things that aren't going to work? I've got this instrument. I'm not going to be able to write the software for it because it's a pig. So my estimate is this long. How many times has that gone in? And how many times has it happened? It's never been mentioned. So the next little block is initial project design. So what we tend to do is we always provide a prototype. Now that prototype is actually part of discovery. We are saying, you've asked for some screens. Now I want to know how we navigate the screens. So here's a screen we can navigate. It's not doing it, but it's navigatable. It's got buttons that go back and forward. You don't throw it away. It's written to the same standard. So we've got templates that allow us to churn out one of those screens in, I don't know, 8 hours. So I can churn out a custom screen in 8 hours that allows me to navigate. Really, really useful. That takes you from your 50% to your 75%. Now you're getting into an area where you know what's going on. You can actually feel more confident that you're going to earn some money. Sadly, a bit too late, because by the time you get there, you've already quoted. But this is why I'm so scrappy and poor. Then you'll have different design reviews, and they do different things. So people just think design review is for one thing, but it's not. A customer design review is very different than an architectural design review, which is an internal thing. Internal design reviews are very much have different reasons for doing it. So for us, an internal design review is you look at the source code, you say, how do we as a company maintain this in the future? It's a very central and important question for my company. I've got a lot of projects. If I couldn't support them all, it would be a pain in the neck. So we're constantly looking at that. That would all architectures and things like that would be come under that question. How do we support that in the future? And Ian, I suggest you do that before you go down the other. Just saying.
There's a reason why you have this on message and that I can debug it so much quicker.
It's valuable. I'm not saying it's the most important consideration. For different companies, it's different things. I always say the story about the guy who had this massive system, just a huge BI. He didn't believe in sub BIs or anything. It's massive, and somebody looks at it and says, "Well, how's anyone going to look after it?" He said, "Well, when I retired, I'll turn the machine off, and nobody else is going to turn it back on again." All right. Well, there's your use case, then. It's fine. You thought about it. Cool. So everyone's use case is different. I mean, for us, it's central all the way through. You'll see the way we do it, just because we give source code to people we don't want after them, or when I go into a company of a piece of software I wrote 20 years ago, I don't want to visit. Oh, I don't know how this works. It's, to me, it's very central to my personality. I don't do that. So for us, design is really important. So spend some time at the start of a project thinking about how you're going to design it. And I've done this quite deliberately. So you've got process here, you've got design here. When I started my battle with software, I started off and I'm all about the syntax. Very interested in syntax, you know, how do I do this, how do I do that? Once you learn syntax, you go on to other things. If you do it in a methodical way, you do a design next. What is it about my design I didn't like? I didn't like the fact that when I was 95% of a project, which I got there quite quick, that last 5% was a pain in the ass. Whatever language I used, it was the same. Until I was essentially brutally told by my first business partner that I wasn't ever designing my software. So that's why I should sit there and design, and then you'll find that and learn design. You'll find that you'll do better for it. Another plug: I have a book out on some of this. It's a DSH book on Amazon. But the reason why design is in this more important than process is that a well-designed project with poor process will likely succeed, whereas a poorly designed project with good process will often fail. So I think spend a bit more time on design. But once you crack design and you're happy that your projects aren't a complete mess and you're not stressed at the end of the project, that's when you know that you've succeeded. And then you start looking at process. Then you get things like you make a change and there'll be a human factor to that change that you haven't considered. And I think this is probably about my third ever blog back in 2014. And I used Brown on purpose. And this was my view. There's no science behind this. But my view is that if you have a largest project, time becomes better if you do some design. You will spend less time if you do some design. And then there's a point in time where you get a lack of return. So, and there's an area here, which is the grey zone of acceptable. What is acceptable? And again, this is a personal thing. What is acceptable in design? Because the things that you find important may be different things I find important. I've sort of said that. And then you have this bit here, which is just all not design. It's just syntax on a block diagram. And that's it. That's all it is. But we're better than that. We can design. I won't do a question and answer on that. The most important thing, this is where the delivery is all part comes in, is how do we get to that point? How do we get a working piece of code into the customer's hands and then get them to pay us, which is nice, or get them to give us another project, which is nice, or not get us sacked. So these are the areas. So, for example, I'm not big on unit testing. Fabio is very big on unit testing. It's how you feel comfortable working, really, for us. I had too many hours under my belt not doing unit testing, but I've adapted my way of writing software to it. But it's a good way of writing software, and if you don't like a blank VI in front of you, it's just a good way to stop that VI symbol. Documentation. I don't know if anyone's ever been asked to completely document their code. So that anyone off the street can pick it up and look after it. I've been asked that a few times. That's quite an expensive option if you're asked to do that. If you ask me to do that, that's going to cost considerably more than me writing the software. So yeah, there's Agile and various other ways you can write the software. BI Analyzer is a very useful tool. Code reviews are very useful. It's been proven that compared to other ways of getting code quality up in a team, code reviews are way better. The only thing is that people can't wrap it up in a pretty noun like Agile. Sell shitloads of books, go to conferences and talk about it. It's essentially sit your peers in a room and look at the code and learn together. There are rules and regulations, you know. The code review shouldn't ever be a QA type review. That's a different thing. Okay. Collaborative code review is what we're talking about here. You sit down and you essentially go through the salient bits of the code and say how you've written it, and you learn together. It's good for that. You get a big benefit. And what you would end up with if you then feed the outputs of this back into the system is you would then have your team writing code in a similar way, which is a massive benefit. I've seen too many companies that have got genius programmers. So it's a company of eight genius programmers, but it's not a company of 8, is it? It's a company of 1 times 8. It's, you know, it's having working as a team together allows you to build tools. Having a way of working allows you to build tools. Writing software in a similar fashion allows you to share templates and stuff like that. So it's very beneficial and worth putting effort into. So this is how we tend to finish off our projects, just generally, if we have a customer it's difficult to get stuff in and out of, then we have alpha tests, which we call on-site, on our site. Okay. They come to our office. Beta is we've delivered it, it's kind of working, and then we send in updates. Again, we tend to hit that one very early. We tend to iterate very fast. We design, central to our design is, I can really only talk, no, I can talk to everyone else in DSH actually, but central to the way I work is the changes at the end come easy. But a lot of effort into making those changes easy, because that's when you're first going to get hard and fast user information. So it's really worth concentrating on that bit. Final acceptance, sign off. So versions will go D, alpha, beta, so B, then no letter in front of it. For us, that's how we tend to work. But then the most important thing that nobody does is a project post-mortem. So you get the team together at the end of a project and you ask lots of difficult questions. And this is where you need a checklist to ask those difficult questions. So this is why, again, having a process is a good thing, because if you've got those questions on a piece of paper, you can't avoid them, you can't dodge it. Here you go, give me the answers to these questions. That's a different names. So site acceptance, factory acceptance, sign off. Test plan can match the requirements. That's what we tend to do. We test against the requirement. I much prefer it if the customer does it, but we add a lot at the end of our job to sit down with the users. Software engineers don't necessarily like doing that, but I think sitting with the user, running the test, doing the work, learning the DUT, device under test, or learning the equipment, tuning the equipment if it's not a test, all of those are kind of useful things to do. So the back end of a project from beta to final test is actually quite a long part of the project, because I like doing that bit. Because it's the most interesting bit, to be honest with you. It's actually dealing with real life. So, lessons learned. Forcing the positive brain to think about the negative is post-mortems. So, here's some example questions. We've got a post-mortem sheet. But, so discussing what was the original project success criterion? How did the project end? I mean, this is actually a copy of one that we've done. I would say the customer wasn't, but so yeah, we delivered late, but the customer liked us, so that was all right. And that's kind of important. But again, that comes also from being there and delivering early. They had something useful but not quite finished, so that wasn't late. It was actual sign-off. So that made the relationship a lot better. So that's a positive. Then you go, what went wrong? And this was the one where we fed back into our requirements and risk management. So this job was, there was a lot of requirements that they asked for, or they didn't ask for, that they wanted. So nowhere in their spec, which was quite extensive, did they mention calibration? Did they mention reporting? Did they mention? The other aspect was that they didn't have a manual test to confirm the automatic test. So we provided an automatic test, but they didn't have a manual way of confirming it. And they said, that's a real, if you write in test systems, that's a real, gosh, a way to validate what you've done. So that took a great deal of time. But then there's a lot of lists of things in there. So, you know, and quite often there's a problem, you know. So sometimes we try to get the answers from the customer. They won't get answers. There are customers that don't reply by email, which drives me up the wall. But sometimes large businesses work on a significantly different time base than small businesses, shall we say. And then you keep the post-mortem stuff confidential, like I'm not here, and you bung it into its own repository, not in the customer repository, because that gives you the freedom to be critical. You know, we've sacked customers based on this. If the output of the post-mortem is the customers are just deeply unpleasant, and they can be. You know, sometimes customers are a reflection, usually, of the managing director, the people at the top. Those people aren't very nice. It flows all the way through, unfortunately. And some of the best business decisions I've made have been sacking unpleasant customers. I whisper it. Cool. I could answer some questions, I suppose. So there's this is only a think about piece, really, not really a tell you how to do it piece. We do tell you how to do it. The newer stuff, what I'm beginning to look at is what's the return on investment of this kind. So, you know, what's the payback for putting, having a good process? Now, because unit tests are, for example, an investment in time. And for a lot of projects, you're not going to get a benefit from that, but for the odd project, you get a huge benefit from it. So how do you cost that? And the thing generally is that a lot of the process, a lot of the surrounding process is to do with sort of risk management. And the risk part is the why you get late. Actually, going back to that graph. When you're down in the tail, so this bit here is you've not managed risk. There's something risky come up. And that's a bit at the end of the project. And there's a lot of stress involved with that. So we use a process called probability impact control as PIC, I think it's in terms of risk management. You just give you give a risk name, for example, and then you state out of 5 what the risk of it happening. So probability of 5 is the highest. And you've got what's the impact? Oh, it's going to, you know, destroy all life on Earth. Oh, that's a 5 then. What's the control? Is we don't have control. That's a 5. And then you come up with a big score. 5 times 5, you get a big score. And you can mark yourself against those risks, and then you can say, well, if we do this, if we say we have a change management system of some description, then this gives us more control. If your change is the risk that makes your project go down the pan. So there's 2 things you can do then. You can manage the impact of change. So you can manage the probability of change. So you can educate your customer, that will manage the probability. You can have you can design your software that can cope with change, that reduces the impact, and you can have a decent change process, and that gives you control over the whole change. That score then would be radically different than be able to control them. And it's a way you can sort of say to management is, look, if we did this, the risk in our projects would be much better, or the mitigation of those risks would be much better. And so we were trying to think, because what they'll say is, well, what's the return on investment? You know, how much money will we save? This machine that delivers, you know, you rely on the delivery of product. If it's not working, if it's, you know, if it's there, you know, it can be the death of the product. How risky is that? That's a big impact. It's trying to verbalise the worth of these things. just finishing a session on that, finishing dev planning that. But that's that. Anyone got any questions?
On your post-mortem, do you think back how well you did the risk?
The point of the post-mortem is not to do anything to the project. Project's dead. It's a historic thing. So
Yeah.
the point of it is you feed it back into the system, so you change your process essentially.
It's more like how well you scored the risk, because obviously that's on another cover.
Yeah. So
And then you get
what you would do in the post-mortem, you say we've identified that we're not doing enough with risk, therefore we shall put a risk column in the requirements, and that will be how we resolve that issue, and then that will be the action. So it's not, you're not scoring, you know, how well you got on in the project. You're identifying problems with your process. It's a process thing, not a project. That's how you do it. It's made a big difference. It's not something you have to do on every project. I think you should probably do it on projects that go way better than you expected, and you should do it for projects that go way worse than you expected, or even worse than expected. And taking the machine tools way of thinking about it is you should be aiming for a reliable process. So you're as out of control if you're saying this will take 4 years and it takes you a day, as if you say it's going to take a day and it takes you 4 years. You know, that's similarly out of control. I know one makes you much richer, but actually, if you're looking at it as a process, it's actually a bad process. You're not in control, or you're very, very greedy.
Very pessimistic.
As I get older, I can get into the very, very greedy.
Do you have a scale when you're assessing risk against requirements from really high risk, therefore time and material, and minimal risk, therefore like a fixed price? As in,
yeah. So 1 to 5 for us, or we're either going to lean on our experience or sort of say, yeah, that's the point in time we need to do more work on this customer. Usually nowadays it's we go back with documents, say these areas are not defined enough, and we'll do a feasibility of those things. And that's beneficial for 2 reasons. You should always do the risky things at the start of a project. The project manager's view of the world is that you want to tick actions off as quick as possible.
Quick wins. Yeah.
And leave the difficult stuff to the end, and that is disaster. That's disaster for your mental well-being more than anything else. It's just a disaster. You should always pick the most difficult thing to do, at least from a feasibility perspective, get that work done, and you should declare it, because everyone will go, ooh, look how good engineer he is, picking all the risky stuff. But it's made a lot of difference. Those kind of things has made a lot of difference to my company. I mean, what we're tending to share with the DSH staff is horrible lessons we learned over time. And that's been that little graph has made a lot of difference. Made a lot of difference to the way the risk management stuff has made. It makes a difference to how you value your work as well. Because you just say, well, we charge £20 an hour because that's how much I earn. You look at that project, you say, well, actually, if I've quoted £20 an hour and I've reached that, then I'll make some money. But odds are you're going to be down there earning nothing. I did a job for McLaren where I did exactly that. So it wasn't £20, £35. It was McLaren, so I thought, oh, then I might get a free car out of it.
I would add, I completely agree with the fact that it's a great idea to identify the risky bits first and try to tackle them at the beginning. And one benefit of doing that is sometimes de-risking that is not fully under our control, but for example, it depends on someone from our client's team producing a document. that documents some API, or they themselves deciding which type of oscilloscope they're going to use and they're not sure yet. So by identifying those questions early, you give them time to start the ball rolling, and they can produce that document or get that information while you then are freed up to tackle some things that you are clear on. So in a sense, you're almost like starting a second thread of execution, and the project goes more quickly. Whereas if you leave that till the end of the project and you've done everything that you knew how to do, and now you're in the position where the only thing left to do is the unknown bit, you now raise the question and they start their process, but you are blocked. You have nothing more to do because you've done everything. So you're running at one thread at a time instead of multiple threads.
And the other thing is, in that last, when you've gone in to be delivered to the customer, that often is the time that the customer starts thinking about the project. They don't think about it then, because actually, and then the bullshit statement of software engineering is we should have full and complete requirements at the start of the project. That is as hard to do as writing the software. Why would you expect somebody who doesn't know how to do software to be able to write full and complete requirements? Whereas if you present them with something and say, do you like the way this screen looks? Yay, nay. That's you've got a conversation going, and that's far, you get way better feedback. Way better feedback than, here's a 400-page requirements spec that you have to adhere to. One, who wants to read that? I mean, nobody wants to write it, but also nobody wants to read it. I don't want to sit here and go for it.
Yeah, it's like, tell me the specs for the car you want to drive, and it's like, I don't know, if I get behind the wheel, I'll tell you if it feels good or not.
Yeah, and yeah, I just think it's also quite unfair from software engineers to customers to expect them, because it's not hardware, so they haven't got. It's you're molding clouds in your brain. It's not. It's a hard thing to get people.
Yeah, there was a little note around like you did the life cycle of a product and the unit testing bit, and you commented that you don't really do that too much, but you also talked about how you focus a lot on design, and in a way I feel like the two are sort of together, because where I really want unit testing is when the design is bad, and that means the error code I get actually is triggered from something else, is triggered from something else, is triggered from something else. Let's talk about that now. That's when you. It's going to sound horribly cocky now, but we sussed design when we wrote the book, so we don't worry about that. That's not. So we've designed it not necessarily to need a lot of regression testing, but it really there are projects that benefit from. Us oldies call it regression testing, but there are projects. I've got one now that would really benefit from but that's one project out of 300. It's become, and I think if it was a thing when I started doing it, started really thinking about it, and we hadn't done all the work up front, I would be much more inclined to do it. I don't think it's a bad way to write software. I don't think necessarily if you're designing using your unit tests, that's the right place to be doing design. Design is actually prior to that. It's prior to writing code. Yeah, I was thinking more if you have a nicely designed architecture, then it's easier to just test as you go and to write unit tests.
Yeah.
Whereas if it's poorly designed, you need the unit test to tell you all the different ways the program is going.
Yeah, I mean, we put a significant amount of effort into making all of the test. So we test as we go, but we don't write units.
Yeah, which is fair. Sometimes it's that high speed low drag. It just works for what you do.
Yeah, I don't know. It just suits me better. I think you have to find a way to be productive in life. And if unit testing is the way that makes you productive, I think it's a great way to write software. I don't think it's a bad way to write software at all. So the way that SSDC writes software, my company, is I really expect a shitload of changes at the end. So those changes should be easy, really easy, and they shouldn't break the software anymore. By adding stuff, you shouldn't break your code. That's a sign that there's bad coupling in your system. And the other things are we push a lot of effort into dependency management. A lot. I spend 2 weeks pulling the Modbus drivers out of the iLib and so I can embed it in my project. You know, an inordinate amount of time is for us so that we can go, this is my repo, I'm going to download it on that vanilla LabVIEW computer there, and it works. I'm not going to be bringing drivers in. I'm going to bring drivers in. I haven't gone to the extreme of actually keeping the driver ISOs, friend of SpaceX, but we do have gone as far as, you know, we don't keep things at the instrument library, we don't keep things add-ons and don't have it all into the project.
All this is really good though, because like we have some code management, but we really do need to be better about it.
We mainly ever go past prototype though, so it's really hard to.
The really nice one is people say, oh yeah, we got our code under control. Yeah, but 85% of the VIs in VI library, for example, are editable. So you could change how your software works on machine A and machine B by editing code that's not in your project.
Yeah.
So the more you put into the project, the more control you actually have. So something I've been fighting with that library for a long time. But you know, that one, well, there's a few lessons in there, but it depends on the scope. So, don't write software by pulling black boxes out of libraries.
Yeah, there's bad.
The future is going to be hell for someone, not me, but for someone.
It's good for getting something pretty working quickly, but then you need to maintain it.
Yeah, and it's funny. I was thinking. So after you've done design, you go on to process. After you go from process, you then go on to the brains, psychological stuff, because what you're doing is you're chipping away at the things that stop you from being as productive as you can be or want to be. And it's very, it's very interesting. It's very the maintenance side for me. The thing I really liked. I've done a lot of software languages. The last languages I did before LabVIEW were Pascal and then Visual Basic, 5 and 6. 5 I could get into my head. 6 just suddenly went because I went for I just couldn't keep it in my head. It just didn't sit with me. And many other people, because it just wouldn't use Visual Basic 6 because everyone left it. And then I discovered sort of LabVIEW. And while my first LabVIEW program suffered the same issues, it was great until I had to sort of deliver something that worked to a customer. And then there was a lot of faff to get to the next step. I could always go back and remember, I'd go back to a program I wrote 20 plus years ago. Be fixed and out in 20 minutes, It's got a weird brain like that. Because we've always written, as we said there, fractional where we've always written code in a very structured way. So all the elements are essentially the same, but they might be different. Back in LabVIEW 5, you didn't have event structures. You had another way of doing events, but you didn't have queues, so you had another way of doing queues. But they're all there. just do it slightly different way. Cool. Any questions? Otherwise, it's one goal. No participants. Oh, that's a few. Process.
Any other questions from anybody online or in the room?
I don't have a question, but I have just a comment. So again, in addition to fully agreeing with what you said, Steve, which is about the specifications, that no specification can ever be complete, no requirements document, and that's just impossible, completely impossible. If you think about it if from a philosophical standpoint, which it took me a long time to get to do. Initially, when I started coding as well, I was like, oh, why don't I have why doesn't the client or my employer give me a very, very detailed specification and I'll just do it, and why did they change their mind and so on? And I came up with two thoughts. One is that, first of all, a complete specification can never exist. It's physically impossible. Why? Because what does it mean for a system to be fully specified? It would mean that every single pixel on the GUI would have to be defined. It would mean that every single control or indicator in your program would have to be specified, what is called, whether the label is showing or not, whether the caption is showing or not, when it's visible, when it's hidden, when it's colored this way or that way. So you can see that the number of the things in our code is
Well, those are the simple things to design. The technical things to design are, when I press this key, when do I go? What do I enable? What do I disable? What are the gateways? You know, so how do I stop? You know, they're the written database applications. How do I stop people writing nonsense into my database? You know, it's not easy. These places are really hard.
It was the pragmatic programmers, wasn't it? We say that when you get to the stage where you've got a fully qualified specification, that is the program.
Yep.
exactly.
Yeah, no, it's always stale. Documentation is always stale. Requirements are always stale.
So even if you have a great specification, best one in the world, which is super detailed, and after most people will say, well, oh my God, this specification is just brilliant, I'm just going to code it, perfect. Even that won't be complete. There will be things in your software that software does without being written in the document. It's just impossible to write them all down. That's one thought. And the second is, I think it's our job as professionals in LabVIEW or software development to discuss the requirements with the client or with the customer at the beginning, and kind of help them think through the requirements and develop them together. It's unrealistic to expect your customer to give you a perfect set of requirements and then you implement them and that's it. The reason for that is if they could do that, then they wouldn't need you. First place, they would just do it themselves. And as an analogy, you can think of if you go, for example, to a car mechanic, to the garage to have your MOT done or some other repair to the car. We might not be experts in car mechanics. You might know a few things and you might try to give your opinion. Oh, I think this might be wrong, that might be wrong. But you rely on the experience of the professional you go to kind of coach you and explain to you, oh, actually, this might be wrong. You might want to fix this. You might want to fix that, and so on. So you rely on their knowledge to guide you towards the end result. And similarly, a lot of our clients and customers, they bring us in as kind of the subject matter experts, and they rely on us to kind of coach them and say, oh, by the way, have you thought about error handling? You want a log for your errors. What happens if the TCP connection drops? What happens? What do you want to happen if this happens? What do you want? Have you thought about what should happen in this scenario, in that scenario? So it's kind of up to us to kind of to coach or to help the customer think through what they want, essentially, not just to rely on and kind of cross our arms and say, okay, please tell me what you want, and then I'll just do exactly what you want. I won't input anything, and then at the end of the project, we're going to both find out that it wasn't exactly what you wanted. But why? Because we didn't contribute, we didn't kind of pull enough in the beginning. So yeah, basically what I'm going to say in short, and sorry, I'm taking so much time, is basically it's unrealistic to expect that the magic specification will come out of the sky. We have to put work into it and be willing to advise the customer towards creating that.
Well, I think one of the joys of the job is you have to can't just be a software engineer. You get domain expertise, and that's why I do this. I could have learned a lot more to do software, but But why would I do that? It would have been, I want to learn how to shoot boats, blow things up, and I don't know. There's all sorts of things I want to do, and I certainly don't. I've done. Funny enough, I've done a bit of laboratory management system, just LabVIEW database screen. It was a huge project. It's a bit boring. As much fun as making a JCB go.
It was a really fun project.
Yeah, we've been lucky. We've done some very fun projects.
Going back to the specification, one of the things that we do here is because we're often the experts working with people who don't know what they're doing. On our specification sheet, we have a who's put the specification in, and the customer comes to us with a partial specification. And then we'll be like, well, we've added these bits. What do you think about this? And if we've got a who as well, we can be like, Jim said this. Do you agree with it? Because it's actually affecting your part.
Yeah, I mean, so our design review prototype, we normally, if it's for a customer, we have a design review prototype as part of our thing.
Yeah.
And then we essentially tell them what we're going to get, and it's sent out to them to say, no, we don't want to do that. We don't want to do that. And it gets podiums as actions, but it's exactly the same thing. You are helping them along the process, and it's interesting. It's part of the profession. We exist on our returning customers. I think of a couple of years since I had a new customer. But we spread out within our existing customers, and it's because you do that. You can't, you are doing more than you should. But it's also more fun to do that. For the reason I do this is fun.
Yes.
Awesome. Well, thanks, Dave, for sharing all that. Really good